All right. So with a continuation of our problem 1.3, we have a problem over here. And the problem says that a circular hole is punched in a metal plate by a punching machine. If the force required to punch a hole of 16 mm diameter is 180 kilonewton in the metal plate, which is 8 mm thick, find the maximum stress in the material. So you can see that this is a metal plate over here, and we are supposed to punch a metal hole in it. And as you can see over here, this is the area resisting the shear. Okay. Okay. Also, the load of 180 kilonewton, this is it. Okay. And the diameter of the hole that is going to be punched inside is 16 mm. Before we proceed, I want someone to read the question for me one last more time again before we continue.
This is John.
All
A
right.
circular hole is punched in a metal plate by a punching machine. If the force required to punch a hole of 16 millimeter diameter is 180 kilonewton in a metal plate, which is 8 millimeter thick, find the maximum stress in the material.
Okay, so they say our force is 180 kilonewton. We already know who kilo is, so we are going to write it as 180,000. Okay, so 1, 2, 3 Newton. Okay, so that is first of all, we are analyzing the question. Okay, and then also, who other did we saw on our road when we were reading? We saw 16 mm diameter. So our diameter is equal to 16 mm. Good. In a metal plate, which is 8 mm thick. Okay, so our thickness over here is equal to 8 mm. Good. So they're asking us to find the maximum stress in the material. This kind of stress is actually a shear stress. Okay, I told you the symbol for that. And this is unknown. So this is what we are supposed to look for. Okay, very good. Let's quickly move to um our blackboard or whiteboard and see how we can solve this question. But before that, which formula do you think we are going to use? If they're asking us to find for our shear stress or maximum shear stress, it means that the formula is still the same since it is still stress. So it is what? Force over area. Okay. Force over area. You know the force, but I realize that the area is unknown. The other day, I gave you so many formulas for area. The other day, I gave you so many formulas for area. But in this case, you are going to realize that this is the one that we are going to apply. That is what? Area is equal to what? Pi times the diameter times the T. Okay? Take note that the diameter, we have two types. For hollow rods, we have inner diameter and then the outer diameter. Okay, but in this case, we are considering the outer diameter. So our area we are going to consider, our area over here is going to be equal to what? Pi times the outer diameter times the what? Thickness. Okay, with this, you are good to go. Okay, that is why I taught you all the three formulas you can use to calculate for your area. Okay, and this was the first one I taught you. Okay, and I also gave you the second one. This was the second one. Okay, and then this was the third one. Good students who had pen and paper beside them and they were jotting down important things. They had all the formula, okay? So in some cases, some can be applicable. In some cases, they cannot be applicable. So it is good to always know that these three formulas so that it can always make life much more easier for you. Okay, thank you. So let's continue to solve our problem. Let's continue to solve our problem. So this is our problem 1.3. Can anyone read a question for me one last more time again? And this becomes our given. So we are going to write the given down. We said we should always write the given so that at the end of the day, we will not lose marks. Okay. Let's always remember to write down the given so that we will not lose marks. Exactly. So let's go back to the question. A circular hole is punched in a metal plate by a punching machine if the force required to punch a hole of 16 mm diameter is 180 kilonewton in the metal plate, which is 8 mm thick. Find the maximum stress in the material. Okay, so in this case, they told us that our force, which is required to punch a hole of, this is it over here. So let's quickly write that down. So our force in this case, F, okay, our force is equal to the P, which is equal to 180 kilonewton. 180 kilonewton, which is the same as what? 180 times 10 exponent 3, or even 180,000. Okay, good. Newton. So the K is a prefix. Okay, let's continue to go back to our question. Okay, so they say a hole of 16 millimeter diameter. Okay, so let's go and put that as part of our given. So the diameter, our diameter is equal to D. Always remember it's capital D, which is equal to 16 mm. You realize that in this case, it was given to us straightforward in mm, so there is no need to do any convention. Okay, all right. And then the thickness was 8 mm. So let's quickly put that down. So the thickness is equal to 8 mm. Good. So now we are supposed to find the maximum stress. I told you this kind of stress is a what? A shear stress. Okay. So let's proceed. The maximum shear stress is equal to a tau, which is unknown. So I put question mark. So now we can begin to solve our question. Now we are done writing the given. You see, exactly. So let's continue to solve our question. So this is our solution. Take note, failure to add a diagram will even cause you to lose more marks. Okay, so let's try and put down the diagram so that we can be on a more safer side. Good. Let's put down the diagram. Please, can anyone state the Hooke's law for me? Who can state the Hooke's law for me now?
Augustine here.
All right.
Hooke's law states that when a material is loaded within elastic limit, the stress is directly proportional to strain produced by the stress.
Okay. Thank you very much for that. Also, I want to ask you one last more question. What is the meaning of directly proportional?
Okay, directly proportional means the stress being applied on that particular material is equal to the strain. That's if it's going up, it's also increasing. That's directly. So I think a follow-up question can come and say inverse. Inverse means when the stress is going on up, the strain is rather reducing. Yes.
All right, all right, all right, all right. Thank you for making us more history and also looking into the future. That was very, very, very wonderful. As a matter of fact, that was actually my next question. But since it has been answered in a follow-up question, that is also awesome. Anyway, I want someone to give me a review on whatever we learned the last time we met online. After watching the lecture videos, is there anything you have learned? Was there any challenges you faced? Any contribution you wish to add? Hello? All right. So I want to ask a question. And I'm going to mention names, okay? Yes, I'm going to mention names. So my first name is Derek. Darius Akom. Please, can you hear me? Can you unmute your mic and speak to us? Derek Akom. All right. So a question to the general public. What is the unit of stress? What is the unit of stress? Asari Bernard, please kindly unmute yourself and speak to us.
So please, the unit of stress is Newton per millimeter squared.
Thank you very much for that. I want to ask one last more question. Strain has a unit, true or false?
False.
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 Can you explain the reason? Can anyone explain the reason why they think strain has no unit? I need reasons to that.
Okay, sir. Please, strain is the formula for strain is change in length over original length, and the original length is mm, and the change in length is also so it's cancelled out.
All right. That is correct for 10 points. That is awesome. Okay. Can anyone also explain it in a different scenario? It's left with one solution to that. There are actually two solutions to that. So can anyone give me the other solution? Hello, can anyone give me the other solution? Okay, let's do a little bit of practice before we even continue with our solution. Okay, what did we say? Who said that? Asari Bernard, kindly make us history. We are listening.
Sir, please, it's about the strain. The another formula for strain is stress over elasticity, and then the unit of stress is Newton mm square, and then the elasticity is also Newton mm square, so it's cancel out.
Yeah, so that instead of giving you 10, I'll give you 6.5. Okay, the word is Newton per mm squared. If you don't bring the per, it means that you lose marks. You understand me? So it is actually Newton per mm squared. Okay, so you can either choose to write it like this or you can write it this way. Newton per mm squared. You see, so it is written in two ways. I hope we are all on a safer side. All right, so that is very, very, very much correct. And I'm glad at least you were able to tell us something. You were able to tell us something. So let's continue with our solution. The question says we should calculate for our maximum shear stress. So the formula for us, what is the formula for stress? The formula for our shear stress is equal to what? Force over
Force
the
over area.
force over area. And the force that was given to us was what? 180.
180 kilonewtons.
Good. So that is 180 times 10 exponent 3 Newton. All over the area, which is unknown. So in this case, we have to now come and calculate for the area. As part of analyzing the question, you realize that we already stressed ourselves some time ago. So the answer is already known, you see. So this is what we are going to use to calculate for our area. Pi times the outer diameter times the thickness. Okay, good. So in this case, because it's a circular hole, we are going to point. That is what brings about the concept of the pi. So this is it. Our area is going to be equal to pi times the diameter times the t. Yes, so this is the formula we're going to use to calculate for our area. Let's quickly proceed. So that is our area is now going to be equal to our pi we are using in this case is equal to what? 3.142. You see, so 3.142 times the diameter. And what was the diameter given to us? It was 16 and the thickness was 8.
60 millimeters.
Thank you. So that is 16 millimeters times 8 millimeters. Someone should quickly
8
point this on the
millimeters.
calculator and tell us the answer.
The
After
answer
point,
is 402.17.
402.18 millimeters square.
okay, I have a question to the whole class, okay, and that is, if I leave my answer in 5 decimal places and someone leave his or her answer in 8 decimal places, who do you think is going to get more marks?
8 decimal places.
Why is the one who is going to leave his answer in 8 decimal places get more marks? Can you explain that to us?
Because if you leave it in much decimal places, your answer tends to be more accurate.
All right, thank you very much. So you see, at the end of the day, people who were able to return to the lecture videos or people who were able to watch the lecture videos are making history, and their records are being recorded in history. You understand me? So that is why I urge each and every one of us to always have pen and a paper beside us, so that anytime we watch lecture videos or anytime we are in the class and the lecturer is teaching, we can be able to jot down important points. In the future, you may also happen to teach your siblings, your nephews, or your cousins, okay? So that at the end of the day, you can also make them become more history. In the course of doing that, we are enhancing creativity and also we are promoting Ghana to become a better nation for ourselves. All right. So in indices, we said that this has an exponent of 1, this also has an exponent of 1. Because the bases are the same and they are multiplying, our milliliter is going to be what? Squared. That is why at the end of the day, our area is what? Squared. So finally, we can just substitute this into our equation and then we are good to go. So we are still calculating for our maximum shear stress, and that is what? We already know the load. So it was 180,000. So 180 times 10 exponent 3.
Times 10 exponent 3.
All over 4, 0.
3.18.
Point what?
176.
All right. I always told us that we should always try to work with the units. Okay. So this is in Newton and this is in millimeter squared. Anyway, who has the answer to this? Who has the answer to this?
447.565.
Newton per millimeter square.
47.56 Newton per millimeter square.
Okay. So at the end of the day, you all had it correct, but the one with who was able to mention the unit as part of his or her answer is going to be more accurate, okay, because he was more specific, okay. And the one who was able to leave his answer in more decimal places is also going to get more marks. So let's say our answer is going to be 447.565 to let's say 5, okay. Let me just maintain 5 decimal places. Newton millimeter squared. Okay, so let me write it this way. Exactly. All right, so at this point, I want to take few questions before we proceed. Is there any question? Was there any challenges someone faced, or any contribution you also
Sir.
wish to add to whatever we have learned before we
Hello.
proceed? Yeah, hello. Yes, sir. Please, I'm listening. Samoni, please kindly unmute your mic and talk to us.
You'll say. Good evening.
Evening.
Hello, good evening.
Yeah, evening. Please,
So I
I'm
want to
listening, please.
ask,
Okay.
when you punch the, let's say you are doing the calculation, you put the numbers you get, that is the decimal point you get. Should you write or you can choose the number you want? Let's say if it is 6, should you write all the 6, or you can write, let's say, 3 or 4 and leave
Okay.
the rest?
For standard purposes, the standard is just 4 decimal places. Okay. But for precision purposes, according
Okay.
to the standards of physics, for precision purposes, the more your decimal places, your answer tends to be more correct than the person who left his answer in just small decimal places. Do you understand me? So for
Okay.
accuracy reasons,
Okay.
we said accuracy is the closeness of a result to the standard one. Okay, so to be more accurate, for your answer to be more accurate to the standard result, to the examination scheme, then you have to use more decimal places so that at the end of the day, you can be more accurate. Do you understand me? All right, but the standard is 4. You can choose to
Yes,
maintain
sir.
4 decimal
Yes, sir.
places and you are good to go. Okay. All right. So
Okay.
please,
Thank you.
thank you very much. Also, any other question, any other contribution? All right. So let's look at, if there is no other contribution, let's look at problem 1.4. In about 5 minutes time, the link is going to go off. Let's do all to click the link and come back stronger. So our question says that this is problem 1.4. And the question says that find the minimum diameter of a steel wire, which is used to raise a load of 4,000 Newton. If the stress in the rod is not to exceed 95 meganewton per meter squared. This is one of the questions I have been anticipating and expecting X to solve. Okay. Because of some conversions related to this. Okay. Take this example very, 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 very serious. This is a very, very technical question. All right. So let's see how we can resolve this. But before that, I want one or two students to read the question for me one more time again before we proceed to solve the question. So who is willing to read the question for us?
This is Patricia.
All right. Please, we are listening. Kindly read for us.
Find the minimum diameter of a steel wire, which is used to raise a load of 1,000 Newton, if the stress in the rod is not to exceed 95 mn per meter cube.
Thank you very much, Patricia. So she said that we should find the minimum diameter of a steel wire which is used to raise a load of 4,000 Newton. So you see, we can even say 4 kilonewton, you see, but we just maintain that as 4,000 Newton. Okay. And this, as a matter of fact, is the same as what? 4 kilonewton. As simple as that. Okay. Yes. Any other person to continue the reading for us? As part of doing all of this, we are just trying to analyze the question to really understand the question before we solve. You have to think before you talk. That is it. Okay. As engineers, we think before we actually act. Yes. So any other person to read the question for us one last more time again?
Okay,
Find the minimum. I'll read.
Yes, please. I'm listening.
Find the minimum diameter of a steel wire, which is used to raise a load of 4,000 Newton, if the stress in the rod is not to exceed 95 mn per meter square.
You see. So they are saying the stress in the rod is not to exceed 95 meganewton Newton per
meter
meter
squared.
squared. Okay. Okay. First of all, we can dissolve this in a simple form. And that is, we can also write this as a 95. The mega means 10 exponent 6. So times 10 exponent 6. If we really paid attention to our prefixes, well, we should really understand this. Do we all vote or second what I'm saying? All right.
Yes, please.
So
Yes.
this is it
Yes.
over here. This is it
Mega
over
is
here. Mega is equal to 10 exponent 6.
6.
You see,
Yes.
that is mega.
Sure.
All right.
All right.
So let's proceed. Also, this is still having a unit of Newton per meter squared, but we don't want it as Newton per meter squared. It's actually supposed to be expressed as what? Newton per millimeter squared. Okay. So you see, we have to convert this into the other way around again. Okay. Okay. So we are supposed to calculate for the minimum diameter. Good. What is the formula for stress? We know that stress is equal to force over area. Okay, but area was not given to us over here. Do you think we can find for area? Okay, let's say that if we are saying that stress is equal to, let's say, load over area, then it means that if our area is not given to us, and to calculate for our area, we can just do cross multiplication. At the end of the day, we are going to get our area to be equal to what? P over what? The stress. If you're able to calculate for our area from here, then we can now go and calculate for our D from this formula. A is equal to what? Pi D squared over 4. You see. Kindly click the link to join again. Okay. The link is going to go off soon. Kindly click the link to join again. So you see. So we are going to do a little bit of complex calculation over here, and I'll urge each and every one of us to pay attention and ask more questions so that if